What's up guys, welcome back to the channel. Now today on this video we'll be differentiating using chain rule to find the derivative of this function here. Guys, if it so happen that you are new on this channel, do not forget to subscribe to the channel. I would advise you in fact to subscribe because I've made lots and lots and lot of videos on other chapters, and also I'm still gonna make lots and lot of videos in future, and also I'm gonna solve previous question papers as well. So subscribe to the channel and don't forget to hit the bell icon there so that it can remind you whenever I upload a video that is relevant to this subject. Now guys, if you want to watch those videos that I make, you can go to the playlist section and watch videos on trigonometry, videos on limits, videos on binomial theorem, videos on derivative, the first principle, and the other derivatives. Now if you are returning, you can pause this problem and pause this video and do this problem, and let's see if you're gonna get the same answer as the one that I'm going to get. All right, let's start guys. So as you can see, this problem here, it needs some simplification guys. We have a side here. Remember, we cannot differentiate when there is a root here, so we need to change the root into exponent. So we know that we can say this sine 2x is the same as 1 over 2. Now when it's like this, now we can able to identify the type of function. Remember, in order for you to use the chain rule, you need to identify the inner function and the outer function. Now I usually say you must pay attention to what is inside the bracket when it's like this. So this, what is inside the bracket here, it's the inner function, and the whole thing from y to there, that is the outer function. Basically that's how you do the that's how you apply the chain rule here guys. Okay, the inner function and the outer function. So after you identify your inner function and your outer function, you need to equate your inner function with u. Now we can say our inner function is going to be sine 2x, and then our outer function, remember, is going to be, remember the outer function is everything here that you see. So where there is sine 2x, we have to substitute by u. So we're going to write the outer function with respect to u, and then we know that sine 2x has this power of half. I hope you guys can see this one. All right, so when it's like this, now you need to differentiate the inner function. Remember, when you differentiate the inner function, it's du over dx. We are this function is equaling to u with respect to x. So don't say dy over dx, that's u here guys. Okay, so du over dx. Now do not forget, now this is the trigonometric function. Now if you go back and check our trigonometric function, we know that if we have sine is the same as we have sine, and then we have n there, we have x. When we find the dy over dx of this, it's gonna be n cos nx, right? Do not forget guys, this formula here, there is a video that I made explaining these formulas, so go and watch that video if it so happen you don't understand where this is coming from. So let's find the derivative here, so let's do it. So n, which is 2 in this case, this is n, so it's gonna be 2 and then cos 2x. There we go. So this is our du over dx. Now we need to find our dy over dx, du. Don't forget guys, this y is equaling to u, so we are differentiating in terms of u. So this is the outer function. So it's gonna be dy over du. Be very, very careful, guys, right? So this one here, we're just gonna use our standard derivative. Is, if you still remember, half over, or half minus 1. Remember the standard derivative, if you still remember, if we have x and then we have y is equal to x to the power of n, when we derive uh, it's gonna be n, and then we have x and then minus -1. So the power is gonna be n minus 1. So this is what we did here. Our n here, remember, it's half, so we multiply by half, and then we have our x. In this case we use u, so it's gonna be u, and then we say n, and then n is 1 over 2 minus 1. All right, so that is that. So we use this one again. If you don't know where this is coming from, go and watch this video. I'm explaining it way much better than, or thoroughly. All right, so let's continue. Now here, guys, we are done differentiating these two functions. Now in order for us to find the dy over dx, remember we need to find the dy over dx. The formula, it's always like this. It's gonna be your du multiply, no, du over dx multiplied by dy over du. Guys, this formula here I explained is for the chain rule, so I explain how to use the chain rule here on this video. Go and watch this video here, guys. As you can see, there will be 3 videos. The third video is about the chain rule, how to apply it and how to identify. If you so happen you didn't understand how I explain things here, okay, now this is the formula. So when you find your dy over dx, now what is du over dx? Du over dx, we know that it's equaling to 2 cos 2x, right? That is our du over dx. Then multiply by our dy over du, which is, when you look at this, oh, I didn't finish here, it's gonna be half u, and then what is half minus 1? It's gonna be negative half. Okay, so it's gonna be half 1 over 2 multiplied by u negative 1 over 2. So this is our derivative here. But then remember, we cannot leave our answer in a negative exponent, guys. Remember, we cannot leave our answer negative with a negative exponent. Let me just create a space here, right? So let's simplify what we have here. Let's continue simplifying. This 2 and that 2, they're gonna divide each other. Remember, it's a multiplication, and we're gonna be left with on top, on the numerator here, we're gonna be left with cos 2x, right? And then since this u has the negative exponent, so this is gonna be u, and then if we take the u to the denominator, the exponent there is gonna be positive, so it's gonna be half the exponent. But then, guys, we need to change this u. Remember, we cannot leave our answer in terms of u. We need to change this u. If you still remember, at the beginning we said u is equaling to what? U is equaling to sine 2x. So on our numerator, obviously we have cos 2x over, so instead of writing u, now we have to substitute. What is our u? Remember, u is sine 2x, so you write sine 2x, but then look at this u, it is the power of half, so it's gonna be half. Now remember, when we leave our answer, we must leave it in a third form, meaning now we cannot leave it with the exponent that has a fraction. or that is a fraction. So the denominator, the numerator means going to be cos 2x, and then here we change now, instead of writing power of half, we put the square root. Now we have sine 2x, and now this is our final answer. Guys, I hope this one made sense. If the other two videos that I made based on chain rule didn't make sense, I hope this one can help you understand a little bit better when it comes to chain rule. I know it can be challenging, the chain rule, guys, but really it's not that difficult. If you can able to identify the inner function and the outer function, then you're done. Don't forget that you have to equate the inner function with u and the outer function with y in terms of u. So that's what you need to do. Then you differentiate them, and those derivative you multiply them, then you get your final answer. Alright guys, if it so happened that you understood or this video helped you, do not forget to like, and also if you haven't subscribed, subscribe, and also hit the bell notification there, so that whenever I upload the video, you can able to see that video immediately. Alright, and do not forget to also comment if you have anything to share. Share this video with your friends, and you can go and watch the other videos on the playlist section if you want to learn about trigonometry, limits, other derivative as well. Alright guys, at the end of this video there is a playlist where I do these chain rule videos. If this one didn't make sense, you can go to that playlist and watch the other videos that I made. And also I will make more videos on this topic here. Thank you very much guys for watching. Till next time, cheers.